they are kind of aligned at the position that you want them. That doesn't happen a lot, so you can imagine that these precious moments when Parker and Solar are actually right in the same direction are really looked at very favorably.
But I'll say it does happen more often than you might think. We got very excited when we started looking at all the different. There's the radial,
Yes.
then there's let's go around the Parker spiral, and then there's let's be in quadrature.
Yes.
There's loads of great science that we can do.
And then the quadrature is precisely related to the question that he asked.
Yeah.
The goal is to get three-dimensional structures that are coming out, and we'll get it for the first time because we can actually look at it from that and from the inside, right? With Parker being low and actually looking out sideways, and then Solar Orbiter this way, using the Earth as a third vantage point. It has not occurred that we had that kind of data. And yes, the three-dimensional structure is the goal.
Yes.
Fantastic. Let's come on over here. Yes, sir.
Hi, Jim Siegel with Spaceflight Insider. I wanted to follow up on a comment that I think, Gunther, you made about the peepholes. I believe if I heard correctly in the prior pre-launch briefing, that those windows are once the spacecraft approaches the sun, those windows are open for 10 days and then they close. So I wondered, is that accurate? Is my understanding accurate? And behind that window, is it something like a camera where there's a shutter and it takes a quick look at something or measures something, and then are different instruments linked to the same window, or what? How does that work?
So there are 6 remote sensing instruments, 6 cameras, spectrometer, X-ray imager, polarimeter, and then also the instrument that measures the sound of the sun, the solar vibrations. And they are behind these peepholes. And the peepholes are only opened when those instruments are observing. And I think this is a 10-day period, right?
Right. I mean, being scientists, we always want to push things beyond the limits. So for all engineers in the room, yes, it will be 10 days. For everyone else, let's see. Maybe we can extend it, because everything is double fail-safe. These doors, the sliding doors, are the primary safeguard in case anything should fail internally to the instruments. Let's say if an entrance window to one of these cameras breaks, then we still have the window to keep the whole spacecraft safe. But even when the doors are open, we have developed new technologies, new coatings for heat-rejecting entrance windows that keep most of the heat away and only transmit a small part of the spectrum that we are measuring. And so the 10-day windows are centered around the most interesting parts of the orbit: closest approach, highest latitude of the polar observations. But we hope ideally to also take some observations in between, also to help other observatories like Parker Solar Probe get the full 3D view. And in addition, maybe that's one thing worth mentioning, is we have this wide field coronagraph that looks sideways over the edge of our heat shield. So it's imaging the entire space sideways to the sun. And that is very similar to an instrument on Parker Solar Probe, in fact, built by the same team. So that is, in a way, our fisheye lens to get the big picture.
Okay, so these doors that are behind the windows, they act as kind of a shutter similar to what a camera does? The
doors are the outermost part. They are on the heat shield. So they are protecting, I think we had a video of that as well, they are protecting everything on the outside. But even when they... That's right. It's like the lens cap. So these are the lens cap, and they are sliding because there's no one with an arm there to take them off. So they're sliding doors. And they're behind that, we have different mechanisms depending on the telescope. For example, the X-ray telescope only measures X-ray. So it has a beryllium entrance window. So beryllium is a metal. You can't see through it in visible light, but the X-rays just penetrate. So that is its way of protecting itself. And another instrument just lets more or less all the light in, and most of it goes straight out again through the side of the spacecraft. So that is the way of dealing with the heat, while the other one has a special coating that reflects all the thermal radiation and only lets a small piece of the rainbow through.
Thank you.
Mm-hmm.